The next 20 minutes it's about reverse journeys and destination control. So what are reverse journeys? Reverse journeys is, or you have a reverse journey when you go in the wrong direction, or when you have to turn around during your journey to your destination. Actually, in an emergency, it's not the best idea to go in the wrong direction. Or when you look at that picture, from my point of view, from Germany, only one car is going in the wrong direction. When you are from the UK, then you would say one car is going in the right direction. So going in the wrong direction can be a built-in concept, like a U-turn, or sometimes going in the wrong direction is also some kind of fun. So my kids, they like to run up and down escalators in the wrong direction, and they have a lot of fun doing that. So what is reverse journeys at lifts? Actually, it's not going upside down in an escalator like this guy here. There are some rules how the controller shall process in calls. So one rule is that the lift shall not bypass a car call or a destination of a passenger. There's another rule: do not transport passengers away from their destination. And another rule: only stop at floors because of a car call or a phone call. So when we think about reverse journeys, the middle one, it's the one I want to concentrate on. Do not transport a passenger away from his destination. So a simple scenario at the beginning, when you have two passengers at the same floor, one passenger wants to go up, the other wants to go down, both enter the car, one of both passengers has to go in the wrong direction first and then turn the direction. Before I come to destination control, let's have a look to conventional control. How does it work with conventional control? You press an up or a down call button. The passenger doesn't know which lift is allocated until the lift arrives and a direction indicator shows the allocated lift. Sometimes it's supported by a gong. Passengers only enter the car when they do not recognize the direction indicator, or when they ignore the direction indicator. Sometimes people do that when the cabin is full very often. So then they see a space in the lift and they enter the car no matter which direction it goes. In destination control systems, passengers directly get allocated to a car. They directly get informed. When the lift arrives, no direction indicators or any other indicators are necessary, because when the lift arrives and opens the doors, then the passengers will enter the car. There are some destination control systems, they have direction indicators, but very often they are ignored by passengers or not recognized. In some buildings it works when people are trained and when there's low traffic and people trust the system that it will come again, then they will recognize direction indicators and will wait until the lift will come again. So we have two levels of controlling a lift group. We have the lift control itself. The lift control is responsible to process the calls, and traditionally, and this is done with collective control, and each lift has its own lift control. there's something like a brain over that. It's the group control that includes the dispatching algorithm and is responsible to allocate new calls to the lift control. And the lift, the group control, of course, needs to know how the lift control will process the calls to find the best allocation. I first want to concentrate on the lift control and the behavior. And as I said, it is responsible to process the calls. This is quite a simple scenario. It's only one call with a start floor and a destination floor. When we have the same scenario with an additional passenger, the same floor, but the passenger wants to go down, and let's assume that the passengers will recognize the direction indicators. How will this work? They will see the direction indicator. That means only the passenger on the right side will enter the car. The car will return to the floor to pick up the other passenger. So that means the system needs a second stop. When you like spatial plots, you can see the same thing here again. We can see the second stop and only one passenger starts going down from floor 5. The same scenario again, but now the passenger or both passengers are allocated to lift A, and either no direction indicators exist or they are not recognized. So what happens when the lift arrives? Both passengers will enter the car, and the passenger on the left side will first go in the wrong direction, and then you could see no second stop is necessary. Again, the spatial plot, and here you can see both passengers going down and no second stop is necessary. So the scenario with no second stop, and that's the one I want to continue with. So these were quite clear scenarios, and there are some more hidden scenarios with reverse journeys. Start without a reverse journey. We have 2 calls from 2 passengers. Again, the lift control is responsible to process the calls with the collective control. If you like spatial plots. Okay. Add an additional passenger, and maybe you already can see what will happen. The car will stop at that floor. Both passengers on the right side will enter. The lift has to stop because of the car call. That means the passenger on the left side will enter the car and will end up in a reverse journey. Then again, we saw that we continue without the second stop. Let's go to the other level, the group control, the allocation of the calls. The group control has the task to allocate new calls in an efficient way to the individual cars. In a three-car group, it's a simple scenario. If there's a new call, or we have 3 existing calls and a new call, if the dispatcher knows how the lifts will process their calls, it is clear that the only choice for the dispatcher, when the dispatcher wants to avoid reverse journeys, is lift 3, because if the new passenger is allocated to lift 1 or 2, this will end up in a reverse journey. But what happens if we only have a 2-car group? The dispatcher has 2 choices. Either to allocate a car, that means we have a reverse journey, or say no lift available. So that's the choice the dispatcher has. We had a discussion yesterday in the CIPSI meeting about destination control in unequal floors. In other scenario, again, 3 lifts, but only lift 3 is serving top floor. If there's a new call to the top floor, that means that the dispatcher doesn't have any choices, and the only choice is to allocate lift 3. If the dispatcher wants to avoid reverse journeys, he cannot allocate that call at that time. I want to come to simulation. Allowing the dispatcher in reverse journeys and not allow the dispatcher to allocate calls with reverse journeys. It's a sample scenario with destination control. It's an ETD algorithm that optimizes time to destination with a 6-car group, quite big cabins, speed 2.5 meters, 14 floors above the main entrance, and 16 passengers per floor. And I guess you didn't read the proceedings up to now. And if you read them carefully, you can see that the top floor only has 20 passengers. It's then later for the simulation where not all cars serving all floors. The first simulation, it's a constant traffic with a demand of 12%. I took both the traffic split for a morning traffic and for the midday traffic, and I run one simulation with 4 hours. So the morning traffic, here on the left side you can see the waiting time and then the time to destination. There's only a small difference between allowing reverse journey and not allowing reverse journey. What we can see that in average we have half of the reverse journey within 5 minutes. So the effect is only a little bit smaller value of waiting time. That looks different when you look at lunch traffic. So you have a more mixed traffic, so reverse journeys are more likely. And what we can see when we do not allow reverse journey, we have an average waiting time of 30 seconds. And with 2 reverse journeys per 5 minutes, the dispatcher has more options to optimize the allocations, and we come down to 20 seconds waiting time when we allow reverse journeys. So that was simulation with single entrance. When you go to double entrance with an entrance level bias of 50% each, we see that the number of reverse journeys are some kind of 3 times higher than with the single entrance. When not all lifts are serving all floors. In that case, only lift 6 is serving the top floor, and that's the reason I took only 20 passengers for the top floor. We have a little bit a longer waiting time when we do not allow reverse journeys, but we come down almost to 20 seconds, the same value like all lifts are serving all floors, and it's almost the same number of reverse journeys per 5 minutes. To go a little bit more to the real world, I applied the CE full day office template with the simulation time from 7 a.m. to 7:50 p.m. I did 4 runs and took the average. I took 2 entrance levels. And these are the results for the first version with allowed reverse journeys. We get peaks between 40 and 50 seconds waiting time. And when you look to the results, when the dispatcher is allowed to allocate with reverse journeys, you can see that peaks get lower. And I switch back to the first picture. You can see that actually only the peaks during the high traffic times are reduced. But actually you have to pay a price for it, and the price for it is the number of reverse journeys per 5 minutes. And again, we can see that during high traffic times we have more reverse journeys compared to the low traffic times. I would like to come to the user interface. When you have reverse journeys, or when you enter the car, it's good to have some kind of reassurance that you are right. So that's kind of a traditional user interface in the car. Actually, it's quite hard to see what happens when I want to go to floor 6. The only thing I know is I will go to floor 6, but not how. And I think we can produce better user interfaces that shows us how the lift will operate. Come to the conclusion. And reverse journey situations are more likely with mixed traffic, especially at peak times, with multiple entrance floors, where not all lifts are serving all floors. With restaurant floors, actually you can, in simulation, you can model restaurant floors like a second entrance floor. This is also true for other business and for other busy floors and in underlifted buildings. That means when you only have 2 lifts, the dispatcher has less choices. Finally, it's to consider the traditional design rules that all lifts should serve all the floors, or we have only 1 entrance floor, should be considered also for destination control systems. Although the destination control system is more flexible, but there's still a price to pay. A good interface, a good user interface makes it possible to allow reverse journeys, because if the passenger is informed what happens, then it's less painful. Reverse journeys should be considered as a quality criteria, because when you only look on the waiting time results, we had 2 results of exactly the same system. Actually, I would choose the one with the lower waiting time, but if you don't know that the price for that is the reverse journeys, then actually you don't know what you get. And it's possible that the dispatching algorithm considers the reverse journeys based on the best understanding of the psychology of waiting. Thank you for listening.
Very interesting subject, I think. I think from my perspective, Stefan, I think the big challenge with this is the user interface. and the training of the user. It feels to me to be very counterintuitive to use an elevator and the first direction of movement is the wrong one in your mind. Even if theoretically as an engineer you understand it and you think, I will get to where I want to go quicker by going in the wrong direction. That's a challenge, I think. That's very interesting. Questions from the floor, we have little time. Rory?
Mr. Chairman, gets their shoes.
Thanks. It was very interesting, and years ago, 45 years ago, when I used to sell this, we actually had a control system called single button collective, and you only had one button at each floor, and it did this inherently. Have you looked at what the energy consumption would be with reverse journeys versus non-reverse journeys?
No.
I suspect it would be lower, that it has an additional green benefit, but it'd be something worth looking at.
Okay.
Thanks.
David?
Just an observation, having experienced reverse journeys in a building in London. My observation is because the passenger doesn't understand what's going on, they actually get out at the first stop and then put another call in. So actually the energy consumption may not be as acute as that. And the other thing as well is I like the passenger interface that you did with the sort of tube line map there. But if they're placed too close to the entrance to the lift, people will then start piggybacking as well. And you get 2 people, 3 people going on the same call, knowing the lift's going there without having to put in a call in.
Yeah.
Gina?
Well, this is a very interesting intellectual exercise, and it's not new. 46 years ago, I set that problem to one of my PhD students by name of G.D. Kloss. Are you aware of Kloss's work? The answer is
really.
yes or no.
No.
Not really, it's not good enough. No?
No.
Okay, I do have the thesis with me, and because I'm going to be mentioning it in my presentation. Kloss in 1968 was set the problem by me to consider the reversal of passengers within cars, and by using dynamic programming techniques, admittedly over a small number of floors because we didn't have the computational facilities that we've got today, he showed that there was little difference between allowing lifts to take people in the wrong direction of travel to actually taking them in the direction of travel and dropping them off and then reversing and doing the other direction. So I would like to suggest you have a look at Kloss's thesis and see if it's possible for you to extend the work he did, because it was quite limited. But as a result of what Kloss's work did, he did invent 4 rules, and I'll discuss those this afternoon, and one of which was not to reverse the direction of intended travel of the passengers because it upsets them greatly.
Right.
The other thing that you mentioned was that hall call allocation systems refuse calls unless they can take them in the wrong direction. Hall call allocation systems shouldn't refuse calls unless there's saturation in the system. They should always take people in the direction they want to go. So if there are systems out there, and you said that on page 62, people sometimes allow this, could you elaborate who the people are and how big the word sometimes is?
No, not at the moment.
Good answer, Stefan.
Well, I'll pitch in there because I'm actually a co-author. So most systems do refuse calls currently, and one of the first things I was involved in, that was complaint, and so we stopped it refusing calls. But in that context, in some instances, there is no option but to take people in the wrong direction. Yeah, you can't have both. And we could discuss this at great length, Gina.
We could indeed.
And we will do.
Another question.
Yes, it becomes a bigger problem as the lift is underlifted.
Thank you, Maria-Lisa Siguren from Kone Corporate. Okay. So, Stefan, I was a bit surprised of the thing that the transit time also got shorter. when you imagine that a person has to stay a longer time reversing. Can you explain?
And actually, the improvement of the waiting time or the waiting time and transit time results, it's not only by this 2 calls per 5 minutes. When you compare all the normal calls that do not experience a reverse journey, and you compare it with the few calls with half a reverse journey, the ones with the reverse journey, they have an extreme, or not extremely long, but a significant longer transit time and a very short waiting time. But the big advantage is that when you can allocate some calls to lifts with a reverse journey, you do not, or other passengers with other lifts won't get the worst performance. Yeah.
Any further questions? Peter.
It's not a question, it's just a summing up of that really. And you're sort of saying that the 2 people that are experiencing the worst performance are for the benefit of others.
Yeah.
Yeah, okay.
Just really a comment. When you showed one of the lift actually went down with 2 people, when it could have gone down with 1. So in effect there is some increase in car loading on average.
Yeah, right.
So if you were very near saturation, would you still do reverse journeys, or is there a certain point where you would say above this limit I can't do because my car loading is going up?
And actually that's something what's in progress at the moment. Yeah.
And I would add, actually, what that does is reduce the number of stops. The reverse journey reduces the number, so it could have, the thing is, simulations and controls is not linear. It's complex effect, yeah, because we reduce the number of stops, therefore we've got a shorter average round trip, and therefore we've got a higher hangar capacity. So that might actually even help with that.
Any final questions from the floor?
Just a quick one. From this, are you actually promoting single push landings? Because obviously, if you're not stopping on the return journey to pick up the person who's already in the car, that's actually only reason you're actually delaying, reducing your travelling time. So you've either got two pushes, and you're knocking out both pushes for one journey.
It's only destination.
So it's just a single stop.
No,
a single button.
No.
The destination control.
It's hall call allocation. So you actually, on every entrance, you have every floor. You have all the numbers there. So it's not up and down.
So still, they should be coming back to pick up the call, the destination call that was there originally.
I'm not sure I can explain this. I don't know. Do you want to try and explain? let's talk. I'll do that one over coffee. Yeah, let me explain over coffee.
Any final questions? Jani.
Hello, Jani Sorsa-Kone. Have you conducted any usability studies if users really accept this or not?
Not really studies. No, it's at the moment more experience, but actually I think at the moment our user interfaces are too weak, so that usually we do not allow reverse journeys.